Okay, question 15. Question 15 is more of a theoretical sort of understanding. Okay, so you can see that the whole idea of the Thevenin equivalent, if you look at so far, whenever we say Thevenin equivalent, what are we trying to do? We are trying to take a very complicated circuit, okay, if you look at all the earlier circuits, and we are trying to eventually make it a very simple circuit that we can now connect our load to. Okay, a simple circuit, we just have a single source and a single resistance and then a load in series. Okay, now after I connect up my after I analyze the circuit and get this Thevenin equivalent, the next question that you want to know is what should be the ideal resistance of my load so that the maximum amount of power can actually be delivered to it. All right, because so far we've been seeing that every time I connect a load, okay, to a circuit, okay, it can sort of affect the dynamics of the circuit in terms of the voltage or the current that the load experiences. Okay, but now when I do Thevenin, I can now simplify the whole circuit. And after I simplify the whole circuit, what kind of resistance should my load have so that the maximum power can be delivered? All right. So to analyze that, we're going to look at it from a mathematical perspective. All right. So we can see that this Thevenin equivalent circuit, the current that flows in, okay, this current I can be written as Vt, okay, over RT plus RL. Okay, and the power that is delivered to the load is I square R. Okay, so it will be Vt over RT plus RL square multiplied by RL. So I can sort of rewrite this as this. Okay, and what I want is I want maximum power transfer. Okay, and we know that when my load changes, my power changes. All right, when my load changes, the amount of power that my load will experience will also change. So the two varying factors here that I need to consider is how the load affects the power. All right, so in maths we have learned that to find maximum or minimum, you usually differentiate. Correct. So if I take the differentiation of the power with respect to the load, okay, and then I solve this. Okay, so I'm going to not go through the whole steps. Okay, but if you have done differentiation before, you know how to apply a product rule and quotient rule and all these things. Okay, so all the steps are actually shown here. All right, and if you look at this, all right, the time where I think the important thing to understand from this, okay, no, don't be too worried about the maths. The important thing I think the takeaway from this is the maximum power will be delivered to the load when RL equals to RT. Okay, when RL equals to RT. Okay, so when you derive the final Thevenin equivalent circuit, okay, what it tells us is very important because it gives us the Thevenin equivalent resistance. That means when I know the Thevenin resistance, I must find a load with a matching resistance. Then I am sure that the maximum power will be delivered. Okay, if my load does not have a matching resistance, okay, it will still work, but I will not get the maximum power delivered, okay, to the load. That means I might waste a lot of power within the internal resistance, okay, the Thevenin resistance. Okay, and that is actually characterized by this sort of graph. Okay, so if you were to do an experiment, okay, if you take a circuit, you build it and you try to change different values, okay, you can try and see. If you build a simple circuit in one of the studios, if you're free, okay, if you build a simple circuit like this, okay, and you try out different values, you start off with 100 and maybe 10, okay, and then from 10 you keep increasing all the way to maybe 50, maybe 100, 150 and 200 and so on. You will come up with a graph that looks something like this. Okay, that means only at the point when this and this are the same, okay, when you do your measurement, you will find that you get the maximum power delivered to the load. Okay, so that is one of the significant things about the Thevenin. Okay, so we simplify the analysis, but it also tells us what should be the resistance of the load, okay, so that I have the maximum efficiency. Okay, so that is question 50. So again, the maths part, don't be too worried. Okay, it's just to give you the idea of how we go about doing it. All right, so in maths, when you want to find maximum minimum, we differentiate, and when we set it to 0, you can find the maximum or minimum, okay, based on the relationship between the two variables. So in this case, it is the power with respect to the resistance.